Hey again, everybody. I thought we'd go ahead and kick it up another notch because there's so many notches to kick it up. And we're going to do y equals x squared again, but this time instead of bounding it with the x-axis, I'm going to bound it with the line y equals 2. Okay? So you've got yourself your normal x squared, like we've grown accustomed to, but I'm also going to graph the line y equals 2. So y equals x squared, y equals 2, which means my region, instead of being down here like it has been, it's actually right here. Okay, so x squared, the line y equals 2, and obviously the y-axis, I guess technically 2, right? This is the region I want. Okay, I'm bounding it by those two lines in that curve. And I want to actually revolve around this line, y equals 2. I'm not going to revolve around the x-axis. Okay, I'm going to revolve around the line y equals 2. So that means this orange shaded region is being revolved around. Okay, if I try to draw that, basically looks like some kind of, almost like a bowl, really. Although a filled, right? A filled bowl. If I do a cross section, I've got another circle. Right? Think about that as, again, it's got a little depth to it, so it's a disk. But really all I'm going to be focusing on is the radius, right? Because we know volume, this is not changing. This is not changing. Okay, we're going to keep doing that. So I need to focus on what this radius is. And that's going to be the slight twist from what we're used to. It's not the function. Okay? In this case, what are we doing? We did 0 to, I guess it would be square root of 2, right? Okay, if I made that 2, so square root of 2. And it's going to be r squared. R is the distance from this line to the curve. So it's not just the function. The function goes from x up to the curve. So really what I want to do, actually, here I'll draw it in orange. I really want to go all the way down, right, which is 2, and I want to actually subtract that, which is x squared. So it's going to be 2 minus x squared squared. So my radius is 2 minus x squared. Let me do that again. Here, I'll do it on the side here. The distance from here to here, right? That distance is clearly just 2, right? Y equals 2. So that takes care of, that would be if the radius was all the way down. If I revolve the x-axis around this line, I'm going to get a cylinder with radius 2. But I got to cut out all this stuff, right? I don't want this here. So this big R here, this radius all the way down has to be shortened by that amount. How much is that amount? Well, whatever x squared is. If I drew my circle over here, right, I'm going all the way down for my R, and then I'm going to cancel out this whole part here, which is x squared. So this radius is 2 minus x squared. They're all 2 minus x squared. Okay, and then once you get there, you can just solve. All right, so again, y equals x squared bound by a different line, something other than the x-axis. You revolve around, you have the same concept, it's still this, that's not changing. The only thing that changes is you got to figure out what r is. So your focus should always be on where is the radius and how do I get it. In the first few examples, the radius was always just whatever the function was because I was always using the x-axis. But as soon as we start to venture off and do something else, we have to really focus in on what the radius is. Okay, so it's not necessarily the function anymore. In this case, it's going to be 2 all the way down minus whatever was here. And in that case, that's the function. So in this case, it was 2 minus the function. And then the rest you can calculate out. At this stage, it'd probably be, you'd just be using the calculator. Okay? All right, let me know if you have any questions on that. That's where it starts to get tricky. The next example will have a hole in it. Okay? Let me know if you have any questions. Did I say that already?